Today, we will see some examples of proportion. Maria uses 12 eggs to bake 3 cakes. Sanika uses 40 eggs to bake 10 cakes. Does the ratio of the number of cakes baked by Maria to the number of cakes baked by Sanika and the ratio of the number of eggs used by Maria to the number of eggs used by Sanika make a proportion? Here, the ratio of the number of cakes baked by Maria to the number of cakes baked by Sanika is 3:10. Similarly, the ratio of the number of eggs used by Maria to the number of eggs used by Sanika is 12:40. We can write 12:40 as 12 by 40. If we divide the numerator 12 and the denominator 40 by 4, then we will get the fraction 3 by 10. That is 3:10. As you can see, that the ratio of the number of cakes to the number of cakes and the ratio of the number of eggs to the number of eggs is equal. Therefore, 3:10 and 12:40 make a proportion. We can express the proportion either in this way or in this way. Next example. Prove that 13, 39, 15 and 45 are in proportion. Represent these numbers in proportion and identify the extreme terms and middle terms. 13, 39, 15 and 45 will be in proportion only when the ratio of the first two terms, that is, 13:39, is equal to the ratio of the last two terms, that is, 15:45. So, to prove that 13, 39, 15 and 45 are in proportion, we need to prove that 13:39 is equal to 15:45. We can write 13:39 as 13 by 39 and we can write 15:45 as 15 by 45. Can you tell what we need to do to find out whether two fractions are equal or not? Think for a while. Let me tell you. In order to find this, we will convert both fractions into their simplest forms. In 13 by 39, the HCF of numerator 13 and denominator 39 is 13. If we divide the numerator and denominator of 13 by 39 with the HCF 13, then we get the simplified form of this fraction 1 by 3. Similarly, the HCF of the numerator and denominator of 15 by 45 is 15. If we divide the numerator and denominator of 15 by 45 with the HCF 15, then we get the simplest form of this fraction 1 by 3. The simplest form of both these fractions is equal, therefore we can see that 13 by 39 is equal to 15 by 45. That means 13:39 is equal to 15:45, or 13:39 is proportionate to 15:45. Thus we say that 13, 39, 15 and 45 are in proportion. Out of the four terms of a proportion, the first and last terms are called extreme terms. Among the given terms, 13 and 45 are extreme terms. Similarly, out of the four terms of a proportion, the second and third terms are called middle terms. Among the given terms, 39 and 15 are middle terms. Let us change the order of these terms and see what happens. Suppose we take the order as 39, 13, 15 and 45. Then the ratio of the first two terms will be 39:13, which means 39 by 13. And the ratio of the other two terms 15:45 or 15 by 45. The HCF of 39 and 13 is 13. After dividing the numerator and denominator of 39 by 13 with 13, we get the simplest form of the fraction 3 by 1. Similarly, HCF of the numerator and the denominator of 15 by 45 is 15. If we divide the numerator and the denominator of 15 by 45 with the HCF 15, we will get the simplest form of the fraction 1 by 3. Here, 3 by 1 is not equal to 1 by 3. Therefore, the two fractions are not equal. Now we can say that 39:13 is not equal to 15:45. Thus, 39, 13, 15 and 45 are not in proportion. If we change the order of the terms and write as 13, 39, 45 and 15, then also these numbers will not be in proportion, because the simplest form of 13 by 39 is 1 by 3 and the simplest form of 45 by 15 is 3 by 1, and 1 by 3 is not equal to 3 by 1. Therefore, we can say that if the order of the terms is changed, it is not necessary that they are in proportion. In the same way, find some examples in your surrounding situations and check whether they are in proportion or not. Today, we have seen examples of proportion. In the next video, we will clear some misconceptions related to it.